You're on stage.
Super quick intro and stock thing.
Yeah, okay. Hi, everybody. Still awake? Long day, 12 hours. All that awesome education and knowledge. I could use an extra coffee. All right, let's get started. But before we do, who wants socks? With, you know, the SpringSource logo on it and all that stuff.
We have left. Thanks so much for coming to the booth.
Yeah. Raise your hand and you'll get them. Sock Fairy, giving stuff away. Christmas has come early. Open source socks, that's awesome. Come on.
Well, we had a sock.js library, but they messed up the printing.
Oh.
Yeah, I think so, yes.
Okay. You guys keep your hands raised. We're going to go ahead and get started just for posterity. We have so little time, and I'm sure, like you, you know, there's beer to be had afterwards. So let's get through this. There's a lot to cover, after all. So first things first, my name is Josh Long. Nice to meet you. Hi. That's my Twitter coordinates and my email. Please take it down if you like. If you have questions or you have, you know, feedback on any of the open source Spring projects, I'm the guy you want to talk to. You should feel free to reach out to me. I'm more than happy to answer your questions. I am the author of 4 different books on Spring, and I'm also the Spring developer advocate at SpringSource. Okay, and I'm working on my 5th book, which is Cloud Foundry in Action. I'm also a contributor to these fine projects and many more. I'm also the guy that puts together the RoundUp every Tuesday on springsource.org with a list of community tutorials and blogs and so on that are of interest to people who are trying to keep abreast of all the exciting stuff happening in the Springdom, you know. And I'm the guy that got this guy to work with Spring, just a little bit, you know. Yeah, totally. The muscles from Brussels. I made it work. All right, sorry, silly slide aside, let's get going. All right, so first things first, why are we here? Let's just recap, you know, what brought us here. Spring is a dude, do it.
Got it.
Okay. Spring is a framework, right? I think the definition of a framework is best put by Bob Martin. Software entities, classes, modules, functions, etc. should be open for extension, but closed for modification, right? Spring Framework is just that. It's a nice framework. It's closed for modification, but through the use of very, very cool SPIs, it's open for extension. Spring has always been about avoiding this problem, right? Don't reinvent the wheel. Don't. It's bad. You'll end up like this poor guy. And, you know, he didn't even drink any of the Duvals. He's just been, you know, trying his best. He got lost. So don't do that. Spring itself, for those of you who have been living under a rock, Spring is a component framework. It's a little dependency injection container, very lightweight. And then on top of that, we have vertical technologies to help you with mobile, big data, messaging and integration, batch processing, service tiers, and web applications. By building on top of Spring, you, of course, achieve a decoupling from the underlying runtime and infrastructure, which is handy because now you can build your application in such a way that it's trivial to move it from one runtime to another. In the past, we've seen people fleeing or exiting from larger, more, what's the diplomatic word? More classic application servers to lightweight alternatives like Tomcat, and increasingly we're seeing people move to alternatives today like the cloud, right? So different platforms are out there as well for cloud, and this has created a very interesting opportunity, you know, more so than even before for that portability. And that's actually kind of, you know, that reflects something that's very, very important, right? As important as this stuff was before, it's even more so today, right? We see the exodus from existing application servers to lighter weight alternatives, and we see them moving also to the cloud, right? We see the variety of data stores increasing, the myriad of different data stores. My goodness, I mean, I remember when it was confusing enough just trying to get your SQL to work across 2 different databases, right? 2 RDBMSs. Now, my goodness, you have to deal with NoSQL and NewSQL and not only SQL and all these great SQLs that aren't really SQL, you know. So you have different infrastructure services with which you have to deal with. Data caching is another one where you have a use case that is best solved by caching, but the myriad of caching solutions available is just overwhelming, right? And of course, clients, right? It used to be it used to be that the struggle was building an application that worked predictably on Netscape 4 and Internet Explorer, right? And that was overwhelming enough. Well, now, if you can build an application that works well enough on the desktop across all the browsers, all 6 of them, whatever, and the supported ranges therein, and on the phone, and on the mobile devices that aren't supported by native clients, you've got a lot going for you. You've got a lot of things you have to contend with. It's a different world. So we are seeing people building applications that look very different from what they looked like before, but indeed the challenges are very much the same, right? So the importance of having a framework that tackles these problems head on is even stronger today. It's even more important today. Server-side state, of course, is kind of one of those things we've managed to get rid of. Good, I'm a fan. We've seen people kind of converge on RESTful API endpoint type applications, which are consumed by clients, be they native Android or iOS applications or HTML5 based applications and so on. So okay, yeah. I mean, the use cases today are different. We see this triangle. This is a very old triangle. For those of you who have been using Spring for some time, you may recognize this from, forever. It's a very old triangle. Basically, it describes the 3 pillars of Spring. Spring provides value by providing the dependency injection mechanism, which is actually a very small piece of it, right? But it's the part that everybody thinks about first when they get used to Spring. Dependency injection is a form of information hiding. It encourages good, clean design. We also provide aspect-oriented programming. Aspect-oriented programming, of course, is a nice way of injecting logic into your beans without actually modifying the beans, right? It's a good way of changing a lot of objects in one swoop. And then where we can't influence the behavior of your application and the behavior of your beans through sheer AOP and dependency injection, we provide APIs, which either provide value on top of existing APIs or provide new value that doesn't exist and simplifies things, right? And that's the portable service abstractions. Those are the APIs, If you're going to depend on Spring, let it at least be so that you achieve something that is otherwise very, very hard to do or impossible, right? And in addition to that, I think it's useful to think about it in terms of the blueprints, right? Spring, of course, was born out of a book. It's in the DNA. The technology came out of a book. We've always espoused best practices first, and if you understand the best practices, Spring follows, right? Okay, so Spring 3.1, having rehashed all that, just show of hands, how many of you are using Spring 3.1? Okay, so some of this will be rehashed, just a quick kind of restatement of where we are, just so we can see the path that we're taking into the new stuff. Spring 3.1 was released last year, December 2011. This included support for environment profiles, Java-based configuration, declarative caching, Servlet 3.0 based deployment, and of course Java 7 support. In a lot of ways, this built upon the stuff that was already laid down in Spring 3.0. Some of the key features that you might look at when you look at Spring 3.1 include the environment abstraction, profiles, Java-based configuration, a revamped test context framework, the caching abstraction, Servlet 3.0 based web applications, a much improved @MVC controller model, and integration with third-party libraries like Quartz and Hibernate 4 and refined JPA 2 support, as well as support for Java SE7, tracking a lot of the standards there. The environment abstraction is one of those things where I personally couldn't have imagined the love that people would show. I mean, it's a useful feature, but my goodness, the people that love this feature, it comes out of the woodworks, The environment abstraction provides a way of describing beans that are tagged in such a way that you can activate groups of beans by this tag, okay? More specifically, you might imagine a data source in development that's embedded and you want to use it then, but when you go to production, you have a different data source altogether. This is a very common use case, right? Increasingly so now that we have applications being developed locally and then deployed to the cloud. You have very divergent configurations for your data sources or for your beans in general. and it helps to be able to partition those along the environments in which they're run, in which they're used. So historically, we've seen people extract that stuff out into separate files and do all sorts of things to allow you to achieve that indirection. Well, the environment abstraction and profiles in particular provide a nice, clean way of solving that problem. Here's an example. In the XML, we have the beans tag, and the profile at the top there is production. And we've got a bean named data source, relying upon the Apache Commons database connection pool. And then for the embedded tests, for the local JUnit and the integration tests, we have a different data source, right? Thank you. So, they're both data sources, they're both beans, but only one's going to be active, assuming you activate one profile, right? So it's up to you which one you activate. And of course, you could activate both, but that would cause an error, as both beans have the same ID. This also works, of course, in Java configuration. It's easy to activate different profiles by specifying command line switches, or by specifying you can actually influence the environment object on the application context itself directly and programmatically. So this aligns very nicely with the Spring 3.0 configuration, @configuration style. And we have other improvements in the @configuration style. In 3.1, mainly we've taken some of the XML namespace elements that have turned on certain features. Usually these are one-liners. It's usually something : annotation -driven, right? Spring provides lots of services, but you have to opt in, right? So it's just usually it's just a one-liner. We've provided in Spring 3.1 a annotation for to map to a lot of these different features, right? So it's not equivalent, it's not one-to-one, but usually it's pretty a natural mapping from one to the other. Examples of where we do this, of course, include transaction management, the Spring MVC setup, aspect-oriented programming, etc., right? So here's an example. Here's a configuration class. For those of you who haven't seen it before, it's just a class. If you kind of close your eyes, you can actually see it's basically an application context defined in Java, right? You have a class, it's got @configuration. Each method is annotated with @bean. Spring will look at the methods, it'll invoke the method, take the returned instance, cache that, provide the lifecycle services that Spring provides for all beans, and then provide the services that Spring provides for all beans, and then register that in the application context and make them available for injection and other components. If you want to reference another bean from one bean, you can just call the method, as we are doing in the transaction manager example here. So the platform transaction manager bean, the class in this case is platform transaction manager. The ID of the bean is txmanager, the method name. And the object that's being managed by Spring is the Hibernate transaction manager instance. We're calling session factory. We're actually just invoking the method. Now, you might think that this could be a problem, right? What of Spring's promise of scope? Well, in this case, that's entirely preserved. So when you call session factory, Spring checks the context first for an existing instance. If it doesn't exist, it creates it. And all subsequent invocations will get that cached, pre-created instance. So you get a singleton, just as you would expect, assuming you have not specified a scope otherwise, right? Interestingly, up until Spring 3.1, that would have, you wouldn't have had a way of turning on declarative transaction management. You would have had to use the XML element like that, tx::annotation driven. But here we have a nice little annotation, @enable transaction management, and you can specify different things, roughly as you would inside the XML. We've also included a revamped test context framework, right? This framework is profile aware. So for example, if you run your unit tests, you can tell your unit test to activate certain profiles when they run so that you get the right instance of a bean. And it's also annotation config aware, right? So you can actually tell the test context framework to depend on Java-based configuration classes. We included a nicety, the C::namespace. The namespace is very convenient for use with bean configuration. It's analogous to the P::namespace, which we had in previous versions of Spring, except that it resolves constructor arguments, whereas the P::namespace resolves properties. It's just a shortcut. It's just a way of shortening the construction of beans inside of XML. Admittedly, not the biggest feature, but it's very handy if you really want to squeeze every space out of your XML. One of the big features that I particularly like, and which I've seen a lot of uptake with, is the cache abstraction. The cache abstraction is basically two parts. It's the cache manager and the cache abstraction itself in part of the org.springframework.cache package. Up until Spring 3.1, we actually had a couple of classes in that package, but those classes were, they never really evolved, and they certainly didn't provide the level of functionality that we have right now. They were just utility classes, okay? Now we've actually got an SPI that you can actually plug into, right, in terms of these two classes. We have provided support for a few of the common caches, like EHCache, of course, and Java.util.map-based caches. But we've seen in the years since the creation of cache manager implementations by a lot of different projects. So if you're looking at, for example, Gemfire, there's a cache manager implementation there. Redis, Spring Data Redis provides a cache manager implementation. Infinispan provides a cache manager implementation. Hazelcast provides a cache manager implementation. I mean, it goes on, right? There's more than likely something you can use. And if there isn't something you can use, then in the worst case, more often than not, those caches will have a type that can be cast down to a java.util.map, right? So key values, in which case you can use the simple map cache manager, right? Simple concurrent map cache manager. This is nice, of course, because it gives you the ability to take advantage of this wide range of caches in your code. It's a concern that we've long relegated to lower level code, like for example, perhaps the second level cache in Hibernate, when, let's be honest, it really belongs at a higher level at your service tier, right? That way you're not coupled to Hibernate, for example, to provide caching for your data. You might want to work with web services or NoSQL data, for example. And of course, a very common use case is using profiles, the aforementioned feature, to handle caching in tests using regular java.util.concurrent hash maps, and then in production, you might actually have a more robust cache like Redis or whatever. So very, very convenient arrangement there. The caching support itself is very simple. To cache something, you annotate a method on your class and your component with the @cacheable. Spring intercepts the calls to that method and caches the return value, so that based on a key created by the parameters to the method. So the key itself is generated by the parameters to the method, in this case by default. So the owner there will be keyed to the ID that's passed into that method, and all subsequent invocations of that method will refer to the same cached instance until you evict it from the cache, in which case it'll refetch the object from whatever source data store it was living in. You can be very specific about the types of caches you use, in terms of the way that caching is actually handled. So for example, you can specify conditions. Conditions like, for example, using the Spring expression language in this condition expression here. Here we're saying if the length of the name is less than 10 characters, then we can go ahead and cache this. Otherwise, don't bother caching it. This is an entirely arbitrary expression, obviously. The Spring expression language is very powerful. You can actually call methods on other objects and other beans in the context, for example, to make this decision if you like. So you can really create some very sophisticated algorithms and some very powerful arrangements here. And of course, for everything you put into the cache, it's helpful to have a way of getting it out when appropriate, right? So we have a declarative annotation there as well. We have @cacheEvict. When @cacheEvict is called, when a method annotated with @cacheEvict is called, that region specified will be flushed of the object whose key is provided by the arguments, right? So ID in this case might be 5, and that will evict the record in the cache with the key 5, just as caching it would put it in the cache. @cacheable would put it in the cache. So Servlet 3.0 based web applications is actually one of the nicer features, I think. Servlet 3.0 provided a lot of very convenient features that we were able to take advantage of in the 3.1 generation, and which we've been able to build upon for 3.2. Tomcat 7 and Glassfish 3, of course, and increasingly a lot of other implementations provide good support for Servlet 3.0. One feature that a lot of people were looking forward to was the Servlet Container Initializer apparatus. Basically, implementations of this class found on the class path will automatically be invoked and given a chance to construct programmatically the web, the equivalent of the web.xml, right? The servlet context. And we've built upon this to provide a callback that you can use to programmatically construct your dispatcher servlet and set up the Spring MVC and Spring Web machinery. This is very convenient because you can now assemble very complex sort of arrangements here based on conditions and so on, taking full advantage of the Java language to build your web application instead of hoping it all just sorts itself out inside of web.xml. Interestingly, I don't know that a lot of the vendors, a lot of the implementations actually tested this stuff. So it took a long time for these different implementations to all work consistently, and we tracked the support out of the different implementations and made it work as best as we could as they provided new point releases and patches. And now I think with Spring 3.1 and some of the later point releases, it works very, pretty uniformly across all the different implementations. We've also taken advantage of some of these other nice support inside of Servlet 3.0. Nice to have, right? It's not like these features didn't exist before. It's just these are now baked in. So Servlet 3.0 specifies a standard way of describing file uploads, right? Most of us, I'm sure, have been using Commons file upload and such for handling these kind of things in the past. And indeed, if you have Commons file upload on the class path and you're using Spring MVC, it'll automatically register that and take advantage of it for you. But if you're in a Servlet 3 environment, it'll take advantage of the multi-part, the JavaX servlet.part APIs and so on. So you can use that mechanism as well. This is all sort of hidden for you. You don't have to really be aware of this. It's just nice to know that it's there if you want it. And one of the things we didn't tackle in the 3.1 release was support for asynchronous request processing, a very common use case that was made possible, but indeed not broadly used enough in the Servlet 3.0 generation at that time. So we let that happen. We deferred that until Spring 3.2, which is the thrust of what we're going to talk about today. Here's, by the way, a Java-based web application initializer. Right? It's just a class that implements web application initializer. When the Servlet 3 container sees this, it'll construct it for you and let you construct your annotation config web application context, or your whatever web application context you want. Right? I'm using annotation config here. Of course, you can use XML or whatever. So here we have annotation config web application context, and then we're registering a package that should be scanned, and we're actually registering a Java configuration class as well that Spring should consult to look for bean definitions. And then we're programmatically actually adding the listeners, the root, the context loader listener, which is typical of many different Spring applications. You can also add the filters and add the dispatcher servlet, etc. You can see there's a lot of power here, right? With this mechanism and with a lot of the other stuff introduced inside of Spring 3.1, there's for the 80% case, there's no reason at all to be using XML. It's very, very, very clean, very, very, very nice. Very nice arrangement. At MVC refers, of course, to the Spring MVC component model introduced in Spring 2.5, the annotation-centric Spring MVC. And in this latest and greatest version, we've upgraded the internal machinery somewhat. So if you're into this sort of thing and you're interested in tailoring the framework to your specific use cases, you have more hooks with which to do that. One of those is the request method handler adapter, which now has been refactored greatly to allow mappings to handler methods to be split across multiple controllers. Previously, this was a little difficult for controllers that would have handled the same URL, right? But different methods, for example. That would have been difficult before. Now it's very easy and it's very natural. And we've also provided SPIs that you can take advantage of, like the handler method argument resolver for tailoring the way arguments to methods in Spring MVC are processed. So for example, if you're using a Spring MVC controller and you have an argument of multi-part file, that multi-part file is processed as a file upload, and it's, it looks in the request and an object is made available to you, right? Well, that's all thanks to a handler method argument resolver. We can also handle different types of return values, right? So if you know about Spring MVC, then you know it's possible to return different types of values from controller methods. Right now, for example, a string can be used to resolve a view, or an object like a view instance can actually be used. And you can add your own. You can actually add your own behavior and your own processing here. We also introduced the flash map support. This is a common use case, which is you want to support the redirect after post pattern. So for example, suppose somebody submits a form in Spring MVC, and you want to redirect to another page so as to escape the back button problem where hitting the back button resubmits the form. But you want to be able to persist data long enough to be able to present it to the user, perhaps to confirm the transaction or to retain some sort of state so that the user can track what's going on. But you don't want that data to live beyond the forwarded page. You just want it to live long enough to be presented once, right? So that's called a flash attribute, named, of course, I think, for the Ruby on Rails attribute that they had, debuted several years ago. Now, if you inject a reference to a redirect attributes in your handler methods, you can add attributes that will be persisted beyond one redirect. Then you can use them. They're available to your request for display in the view, for example, and then they're expired after the rendering of that view. This is very convenient, and it's just, it's a nice feature to have there. And it helps keep session management and garbage collection chores to a minimum. Yeah. We've also very, very greatly enhanced the JPA support inside of Spring 3.1. It's possible now to completely use JPA without ORM.xml or persistence.xml. This, I think, along with the web.xml support, is very nice, right? It's a very clean arrangement. You don't really need to get mired in all these descriptors and so on. Just construct your objects using Java configuration and take advantage of the support, and it's all very programmatic and very testable, and the compiler gives you a lot of feedback. We've added a packages to scan property on the local container entity manager factory bean, which can be used to tell the entity manager which packages to automatically scan for components for entities. This is very similar to what we have in the Hibernate support inside of Spring, the org.springframework.orm.hibernate 3 and 4. We've handled support for persistence unit lookups, right? So you can actually resolve JPA context by persistent unit names. You don't actually have to specify that using the annotations if you want. The JPA specification, of course, is based on the very, very strongly on the notion of persistence unit names. So now if you want to inject a specific entity manager by a name, you can just specify that in the annotations. And similarly, you don't need to specify a JPA transaction manager to set up the unit. You can actually just specify the name and it'll be resolved correctly. One final thing, one of the things I quite liked was some of the libraries, the third-party libraries like Hibernate and Quartz have been brought up, right? So we tracked Hibernate, very common ORM technology. We tracked Hibernate 4 as long as it was in gestation. And as soon as it went GA, we were ready to go GA as well. So a few days later, Spring 3.1 went GA. The support for Hibernate 4 is in the whole Hibernate 4 package because a lot of the changes inside of Hibernate 4 were backwards incompatible. The support looks very similar to what we had in Hibernate 3, so if you're familiar with that, it should be fairly simple to take advantage of the new arrangement. Similarly, for those of us who've used the Quartz job and scheduling engine, there's a new version that's backwards incompatible, and this new support is very palatable. It looks very familiar to what you've got in the 1.5 stuff that's been there for a long time. And of course, we tracked Java SE7. So there's a lot of nice features in Java SE7 that make it quite attractive if you can take advantage of it. We don't, of course, require Java SE7, but if it's there, we make it easy to take advantage of some of the nice features. So JDBC 4.1, for example, is now a nice feature with some extra conveniences that are worth taking advantage of inside of our JDBC template and so on. Similarly, the concurrent support, the java.util.concurrent support for fork join, this idea of spinning off work and then aggregating the work, has been folded into the task executor hierarchies that Spring provides. We've noticed that Java 7 seems to have, we think there's a good reason for a lot of people to converge on Java 7. JDK 7, IBM's JDK 7 has come out already, and OpenJDK 7 was out as well. The Sun JDK 7 was out, all within a very short amount of time. We got good JDK 7 implementations that you could take advantage of. So we expect that there's a lot of people who will take advantage of this release because there's not a lot of particularly backwards incompatible features to it, and it's a nice release that provides a lot of stability and value adds for projects. Okay, one of the sort of less user-facing changes, but I think a particularly interesting one, is that the Spring framework proper has been moved to GitHub. Okay, so a lot of the different projects at Spring Source were already on GitHub, and they had been there, in some way or another for the last couple of years. But the Spring framework has been moved to GitHub, and the build for the code itself has been reworked to use Gradle. The net effect of this is that what was already a very active and vibrant open source community has become even more. I mean, really, really, really vibrant. The level of interactivity that GitHub has provided is just incredible. We've seen, the number of pull requests. We've seen the number of people who are willing to take the code and start playing with it and building it and so on, just increase very, very rapidly. And this is good. We encourage people to take the code, play with the bits. If you have something that you feel you want to contribute or so on, this is a very natural way to do it, right? Sending a pull request is far more intuitive, I think, than having to create diffs and send patches in 2012, right? There are lots of other projects there as well, and you can peruse them at your leisure if you like, and all the other projects at Spring Source are on GitHub as well, so it's a great model for interaction with the community. And Gradle has made our otherwise kind of painful build system very easy, right? The Spring framework itself has a challenge that not a lot of projects have, which is that it has to work with lots of different ranges of different libraries. So most people don't have to deal with a range of jars, right? But as Spring framework is very low level, it has to keep compatibility across a different, a large swath of different versions, right? And so doing that has meant that the build was historically very tortured, required a lot of magic to make work. So it's nice to have that sort of made accessible again through a nice clean Gradle build. All right, so that was just kind of a quick breeze through 3.1, just to make sure we're all kind of on the same page with respect to that. We think Spring in this case will serve as this new support has taken the stuff that we have established in Spring 3.0 and taken it full circle. The caching abstractions and the support for profiles and the renewed web and at MVC support makes it even more attractive for a lot of people, I think. And of course, it makes it a very attractive option for people who are trying to build applications that are Java-centric. As we are tracking Java SE7 and Servlet 3.0, we're hoping that this will make those two revision levels a very common ground for a lot of different people. We noticed that a lot of the application servers have adopted those levels, and there's no reason to expect that they will move to something else anytime soon, as Java 8 and the newer specs haven't moved it yet either. So that brings us to Spring 3.2. Spring 3.2 we hope to have released at the end of this year, very soon. The GitHub and Gradle-based build, of course, are still very nice, and we've also been tracking Java 7. We implemented the async part of Servlet 3.0. So if you want to use Spring MVC and take advantage of the asynchronous controllers, now you can, right? This is a very welcome feature. We've had some hiccups along the way, though. Spring 3.2 was originally going to have Java SE8 support and Java EE7 support, both of which have slipped. Their deadlines have, their release dates have slipped quite a bit. And this has meant that the support we were hoping to include inside of 3.2 could not be included in a timely manner. So as an alternative solution, we're going to ship 3.2 with core framework refinements but at the end of this year, and ship 3.3 or Spring.next or whatever that will be called next year, end of next year, 2013. This means that 3.2, which will come out this year, still has some nice features in it, but we will, and people want those features, so it's good to get them out in a timely manner instead of having a long period between releases. And it means that it's also a very safe upgrade, right? It's very, very, no risk of overwhelming anybody. So 3.2 is obviously the Gradle-based build. We're building against Java 7. We don't require it, again, as before. We have very good support for Java 7, so we've got good support for Java 7 bytecode. That means that we've had to upgrade our bytecode manipulation library, so ASM 4.0 and CGlib 3.0 are there. Asynchronous support in Servlet 3.0 is there. We've actually released a web test framework called the Spring MVC test framework. We've upgraded a lot of the @MVC configuration support, upgraded the Spring expression library itself, and we've also backported some of these features back to 3.12 and 3.13. 3.2, Spring 3.1, Spring 3.2 builds upon the support inside of Spring 3.1. So now we're building on Java 7. We run, of course, against 5, 6, and 7. So if you're using any of those versions, Spring is still very well supported, you know. Yeah. So, okay, on to the code. A lot of that was just sort of high-level housekeeping. It's very important to keep abreast of where we are in all of this. Spring MVC supports Spring MVC has always supported a very clean component model. This is a handler method inside of a Spring MVC controller. You see it's got @request mapping. You specify the URL for the request, and you specify other predicates. In this case, I can specify the HTTP method that should be used when this method is called, when this controller method is called. In this case, I'm saying that all requests to the /upload URL should be HTTP posts, and anything else will be routed somewhere else, right? As it's a post, we can say that we expect a file upload. We specify that intent by declaring an argument of type multipart file. Spring MVC will look in the request, look for the multipart file upload, and wrap it inside of an object which we can take advantage of. Normally, file uploads would be something that might take a little while, and you might consider backgrounding that support inside of some sort of a thread pool, right? This can be kind of hairy because it's very tricky to keep thread pools inside of servlet environments, right? It's not really, there's nothing wrong with doing that in a servlet environment, but it's not really safe territory either. A more natural use case, a more natural approach is to have the container, the servlet specification itself, be aware of how to handle asynchronous requests. So in this case, we have we can take advantage of the servlet asynchronous support. Here we are returning a return value of type callable, and that callable will be used to process the upload and then forward control to some sort of view tier, right? This is interesting because it means that the request for a Spring MVC controller method may be handled in a different thread as the response, in a different thread than the response. This is an interesting decoupling that we didn't have before. And it can make programming a little hairy, but this is still very manageable, I think. You have this callback method, right? You have a callable, and when you're done processing, Spring MVC will call the return method and then forward control to the view. Okay, another common use case is I want to provide a deferred result, which will sort of act as a gate on which other threads can converge. In this case, I want to specify a controller method that has a deferred result that contains some sort of value that other threads can see. And then as soon as that thread sees that value, it can continue processing. So in this case, I have somebody calls quotes, we return a deferred result. The deferred result is available in some other thread. It's made available to some other thread. The thread inserts a value into the deferred result, and that triggers the continuation of processing. This can be very, very convenient. It's very nice to be able to expose results like that and let the thread container passivate the actual thread that the request was handled on. And now, looking forward a little bit to Spring.next or Spring 3.3. As we said, a lot of the stuff that we had hoped to include in Spring 3.2 has been moved to Spring 3.3. So Java 8 support will be included in 3.3 at the last quarter of 2013. We expect to have good support for the Java EE 7 API levels. We will focus on a lot of the message-oriented architectures that are made possible now through the enhanced JMS 2.0 specification, including the annotation-centric JMS endpoint model. We will also revise the application event mechanism and support the WebSocket JSR, right? So WebSockets is a very common, very powerful use case that a lot of people are building or running into now with web applications, and we hope to support that fully in Spring MVC. We have Groovy support, enhanced Groovy support. So part of that includes actually having the Grails bean builder ship finally with Spring proper, right? Finally, and I can't speak for sure, just a hazard, but there is some indication that this new release will be, above and beyond what I've specified here. It'll be a 4.0 release. So it might be 3.3, it might be 4, but there's some indication that it's might be time to make a jump because a lot of the features in this release are substantial enough to warrant a bump. The Java SE side, the Java SE 8 story is very interesting, I think. There's a lot of great features to take advantage of in that language level. And one of those, of course, is lambdas, or closures, right? Spring is well positioned to take advantage of closures because a lot of the proposal as it stands right now for lambdas in Java SE make what are called single abstract method types implicitly lambda friendly. So for example, the JDBC template, which has callbacks that have one callback method and take an argument, can be rewritten without any change to our code using a lambda. You can just provide the single interface. You can provide a lambda that matches the contract of the single method on the interface. So for example, if you're using the JDBC template and use the JDBC callbacks, you can just specify the method. You don't have to provide a whole object that matches that. Date and time API has been upgraded significantly, JSR 3.10, and of course support for that will be included inside of Spring and in all the places where that's appropriate inside of the Spring MVC's formatting support and the date time support. We'll take advantage of the NIO supported, the NIO-based HTTP client libraries. This is going to be very powerful inside of, for example, the REST template, which makes calling out to RESTful services dead simple. Parameter name discovery is going to now be officially supported as opposed to the current mechanism, which relies on the availability of debug symbols in the code. And of course, we're going to take advantage of some of the Java.util.concurrent progress being made in the new language revision. We want to continue to retain support for Java 5 and higher. Java 6 and 7 we expect going to be more prevalent. Java 8 we expect will also become common very quickly because it marks a very kind of aggressive release, and a lot of features will probably scramble to take advantage of that, particularly lambdas, right? A lot of the things that people want out of some of these other languages, you might argue, are available in Java 8, and that will make the ease of use of the language much simpler. Java EE7 is also very, very interesting, right? We have a full intention to support a lot of different API levels inside of Java EE7. JCache 1.0 is actually the specification so far. The long since dormant specification has been renewed, and the support for JCache itself, we had every intention of supporting that inside of 3.2. JCache itself as a specification is already very stable, and so when 3.3 or 4 or whatever the new version is called is released, it'll actually be the first way to take advantage of JCache inside of an enterprise Java application. This is very convenient. JMS 2.0, of course, is also going to looks very promising, and we'll take full advantage of that, including of the annotation-centric, message listener container methods. We'll take advantage of the upgraded we'll track the JPA 2.1 and JTA 1.2 specifications as appropriate. The new bean validation spec and servlet 3.1 and the new Java service faces stuff will also be supported. And of course, we'll still continue to track a common revision level of Java EE 5 and higher. So if you're using containers that track that, then that's fine. If you want to move more aggressively, you can as well. So this is one of the pieces that the JMS 2 specification provides, and I think it's going to be very convenient. It'll make it very easy to specify message listener containers using an annotation. If you're using something like Spring integration, then this adds no value, right? Spring integration makes it easy to, with an annotation, declaratively tell the container to treat this method as a callback, just like you would with a message listener container and that whole apparatus. You can see here we're using the @JMS listener annotation, and we're telling it to consult a queue registered on the broker, and we're also taking advantage of the fact that the POJO-oriented methods can just take any old argument, right? So a text message or a string, we could actually specify that we want the text message and we want access to the headers, or we could just say unwrap it and give me the payload, in this case a string, or any of the other various supported payload types, right? You can be very specific. You can actually specify predicates. For example, a selector saying I want to receive only the message that has, that match this selector. WebSocket support. WebSocket support in Java EE8 will be a very interesting feature indeed. WebSocket support is already possible. For example, there's an adapter that has been checked into the code base for Spring integration to support that from a messaging perspective, right? If you want to handle it right now, you can, you shall be able to in a future release of Spring integration. But it'll be nice to see that packaged as part of the specification, right? And in which case, we will support that as best as we can, not only inside of Spring MVC, but also in some of the other frameworks as well, like Spring integration, right? Jetty 9 and other application servers will no doubt support WebSockets ahead of schedule, so that's one of those things that a lot of people have been clamoring for, and we expect to see adoption there very quickly. Okay, so that gives us to that's kind of where we are right now. That's Spring. That's what Spring 3.2 and 3.3 will look like. And at this point, I'm happy to report we have time for questions. Yeah.
You mentioned MVC test support. Can you say?
Yeah. So the MVC test framework support. The idea is that we want to be able to unit test your @controller methods in a convenient way, and this framework is a superset of the test context framework support that we have inside of the core, right? So now you have a way of unit testing MVC-based controllers, including mocking out parts of the servlet API and so on, right? So if you want to take advantage of that, you can. It's been rewritten from the ground up for this 3.2 release, which you can get, by the end of this year. Yeah, there's a whole apparatus. I mean, there's actually a blog. Rossen Stoyanchev and Sam Brennan have put together some very nice blogs on blog.springsource.org that allow you to that they'll explain all this stuff. I can actually show it if you want, but It's actually been, it's very nice. It's a very nice arrangement. Anybody else? Questions?
What about runtime metadata?
What do you mean? Say that again?
For example, I wire up a new string context of 1,000 bean say, and I have no clue what has been wired up. So is there a way to ask for metadata?
Sure. So Spring itself, well, first of all, if you're looking for information about the beans, it's very easy to inject beans of a certain type. But fundamentally, underneath the hood, the Java configuration, the Grails bean builder, the XML, the annotations, all of them are just different ways of describing to Spring runtime information about beans. And actually, it ends up as a type called a bean. What is it? Bean runtime metadata object, something like that. It's an object that's underneath the hood, right? So it's just a Spring. When it's all said and done, is just a giant bag of these objects. And you can actually get access to that if you want. You can actually navigate that by looking at the configurable application context, right? Any instance of that will have a way of navigating the actual metadata objects, not just the beans, right? That's a little underneath the hood, but that's always been there. You've always been able to look at that stuff from that perspective. Another way to look at that information is to provide a reference to a bean factory post processor. And that'll give you a hook to look at all the beans as they're being constructed. And you can actually do things in a bean factory post processor, like dynamically construct beans to be registered based on a programmatic decision, right? So if you want to register a bean based on some sort of test, instead of actually configuring it at design time, then do it as a bean factory post processor. And that'll also give you a chance to intercept all this metadata and test it and do whatever you want to do with it. Okay? Yep.
And you have no clue what's going on, and you don't want to program bean processes or things like that. You just want to get an idea of what does this thing look like at runtime.
I would recommend using a bean factory post processor. That's the hook that allows you to look at that information, right? That's how we expose it, right? It's part of that callback, and from there you can make your decisions and design and describe the objects any way you like. There are other ways, of course, but that's the most convenient that I can think of at the moment. Other questions? Yeah.
The cacheable annotation, you can cache based on input parameters, but is it also possible to cache on return values? For example, a Boolean method, if your result is false, to don't cache it.
So you could specify as part of the Spring expression language, you can say if the return value is false, you can use that predicate, that condition in the expression language attribute for the annotation. You can look at that and say if the return value is false, then abort, right? Don't cache. Yeah. Sure, no problem. Anybody else? Going once? Going twice? All right, guys, thank you so much. Have a lovely